Hey, good afternoon, everyone, or good morning. This session, we are going to talk about geomorphic processes. So, what the hell are geomorphic processes? So pretty much, just to break down the word, geo means Earth. Um, Pretty sure we've heard that all before, somewhere. And morphic is shape, form, or structure. So Earth, shape, form, or structure. So a geomorphic process are the processes that shape the Earth as to what it is today. It shapes the various landforms, landscapes that we see in our backyard, fields, hills, and valleys. So pretty much it is telling us what processes, what happened to make these things. So we'll start it off with erosion. Erosion is the process by which the surface of the earth gets worn down. Erosion can be caused by natural elements such as wind and water, including rainfall. Water is the main cause of all this because it is so easy for it to move around and it always finds itself going to the lowest point. So this is very, very common in riverbeds where it rains a lot. So places along kind of cliff faces as well. You'll find a lot of rainfall occurs there and wears down a rock. You can see by the photo in the bottom right, that's all through rainfall. So water goes down to the lowest point, and with it, it takes a tiny, tiny bit of rock with it and slowly wears away at the rock. Oh. Next up, we have abrasion. Abrasion is when pebbles grind along the rock platform, much like sandpaper does. Over time, the rock becomes more and more smooth, like erosion, but with bigger rocks hitting each other. So this is more common in places where you have a lot of energy, such as the ocean up against cliff faces. So water will kind of throw itself at rocks, moving rocks, and allow rocks to hit bigger solid rocks like that on a cliff face. And eventually this happens more and more and more. And what will happen is that rocks will chip away at rocks or the bed, like the floor of the ocean, creating a kind of like eating away effect at the cliff face. And you can see that in the diagram there. Next up, we have coastal erosion. This may or may not be a part of a case study, may or may not be, emphasis on that. The process is the loss of coastal lands due to the net removal of sediments or bedrock from the shoreline. Coastal erosion can be either a rapid onset hazard, which means it happens very, very quickly or over a period of days to weeks, or a slow onset hazard, which occurs over many years, decades, or centuries. That bottom picture there is a picture of Wombrel, where I am originally from, down on the Central Coast. That happened maybe 2 or 3 years ago, and that's what happened when king tides came in. A very, very bad storm, and this is an extreme kind of example of a rapid onset coastal erosion event. So as you can see, these houses built on sand, pretty much, very, very soft rock, and it's just so what coastal erosion has done is just eaten away at the sediment, at the rock, sorry, and has just taken the land from underneath these houses, and it has left so much destruction in its way. Luckily, I don't believe anyone was hurt in these events, but the fallout from it was major, major council disputes and residence disputes, insurance disputes. It just opens up a tin of worms. Okie dokie. Next, we have weathering. So, weathering is the breaking down of rocks, soils, and minerals, as well as wood and artificial materials through contact with water, atmospheric gases, and biological organisms. This is like erosion, but more broadly defined. So it's more just kind of material getting smaller and smaller, whether it be through a bit more kind of more broader processes like atmospheric gases and biological organisms. So this could be possibly even wind. A lot of minerals in the ground, when exposed to air, they react differently. This doesn't happen often, but sometimes, you could see, say, what's a good example? A good example, for example, is when a body decays, there's more biological organisms that break that down. So you might have, say, maggots or different kind of bacteria that eat away at that, and it slowly goes into the ground and gets used elsewhere. Alrighty. So we have deposition, which is the laying down of sediment carried by wind, water, or ice. Sediment sediment can be transported as pebbles, sand, and mud, or as salts dissolved in water. Salts may later be sorry, let me spit that out. Deposited by organic activity or evaporation. So we have pretty much just the deposition of a rock. So it goes from bigger boulders to cobbles, pebbles, sand, silt, and clay. And you'll always find it in that order, going from the bottom up. So the heavier things that are more dense and clumped together, which are usually boulders and cobbles, bigger stones, will be found at the bottom. Say if you go into a lake, a still lake, you'll find a very, very thin, almost silky kind of clay or silt on the top of it. It feels really, really weird, but when you get down to the bottom, it gets a bit thicker, thicker, thicker until your foot hits the bottom, and that's that solid rock, which could be a boulder, could be the sea floor, could be, or the lake floor, excuse me, or even pebbles, depending on what it is. But if you leave something to kind of sit there, the thicker, harder clumped stuff will go down to the bottom, and the other stuff will go all the way to the top. So pretty much the the bigger stuff will always be moved into smaller things through deposition and erosion. Tectonic activity. So tectonic plates is what our world is made up of. Couldn't tell you how many there is, but there are a few there on the screen you can count them all up on the side there. What is there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I believe. So tectonic activity is a large-scale motion of plates making up the Earth's lithosphere. Since tectonic activity began on the Earth between 3.3 and 3.5 billion years ago, earthquakes and volcanic eruptions affect people all over the world. They are caused by the movement of tectonic plates. Tectonic hazards can destroy buildings, infrastructure, and cause death. A lot of tectonic activity can also result in volcanic activity. Not so present in Australia, nor with earthquakes. As you can see, you have to be closer to the edge of the plate. Say the Philippine plate, as you can see on the right side of the diagram there. That's why Japan experiences a lot of tectonic activity and a lot of earthquakes. It's because they're sitting right on that plate there. And what that can cause is tsunamis and a lot of other flooding and events, maybe even landslides. Yeah, if you haven't heard of the Ring of Fire, go look it up. Go look it up. That'll be stuck in your head for a while. And finally, we have anthropogenic activity. So this is any human activity that impacts the Earth in a significant way. This is probably the biggest geomorphic process, if you could include it in that. I would personally, because it has such a huge impact on the Earth. So examples of this are polluting climate change, so burning of fossil fuels, and deforestation, which is another major one in Australia. It's not very well known or reported in the media in Australia that we have some of the worst land clearing rates. It also speaks to our care of our even our friendliest, cuddliest animals like koalas. They are slowly becoming extinct because of acts like this. But when you weigh it up with economic activity and jobs and wanting to build houses and whatnot, is it worth it? It's up for you to decide. It's mainly where your morals or values live. Um, it is up to you to decide. But we can all agree that climate change is a massive impact. Overfishing, anything that impacts the earth through humans is an anthropogenic activity.